To start today's session. So is it okay now? So here there is a lot of disturbance today. So is this okay now? Hello. Hope this is okay now. Okay. So I'll recap for 5 minutes and then we'll start today's session. So in yesterday's session we were discussing about when we import data models from BW like info cubes. Info cubes are based on star schema and extended star schema. When we import these cubes from BW to HANA, it creates a star schema in the data foundation. The same star schema I can redesign in a different way in HANA, wherein I can group set of tables and create them as an attribute view. And these attribute views, I can reuse them in multiple analytic views. So when we create data models for HANA, we create them in star join data foundation rather than creating in the data foundation where BW creates a star schema in the data foundation. So instead of we create again in data foundation, we create them in star join data foundation. The difference is we group these master data tables to create attribute views. The second point we were seeing yesterday is we can request attributes from different tables at the data foundation, but not the measures. So in today's session, I'll focus on native HANA modeling, how we can create native HANA data models. So let us go to HANA Studio, click Start, click on the HANA Studio. Double click on the system, provide the username and password. Expand content. So here we have these analytic views. We created them yesterday. So now I'm going to right click on the package, click new, click on the analytic view, give the name an underscore copa underscore actual underscore data underscore HANA. Provide the description. View type is an analytic view. Click finish. Now once we finish, in the start join data foundation, and here we have data foundation. Sorry. Click on the plus icon, add objects, enter the table name CE1 IDA, select the table, and click OK. I'll select required columns, click find, KNDNR, customer ID, ARTNR, material ID, BUKRS, company code ID, VV010, gross revenue, VV070, sales deductions. So I selected all the required columns from the data foundation. I'll close this find. When I click on star join, so these are the columns that I've selected for the fact table. Now quickly what I'm going to do is, because we are using the different system, I'm just using the backup system, but once I created them in the original system, so tomorrow the original system will be available for you. So what I'm going to do, just give me 5 minutes, I'm just going to create the other views, because we're going to use all these tables from a schema called best. So instead of HANA user, I'm going to use from a schema called best. So just give me a right click, new, create an attribute view. I'll just create them. I'm just creating them. We know why we are doing it. So I'll just create. Okay, thank you everyone for your patience to bear with me to create. Okay, so now once we created all these three attribute views, customer, material, and company code, just 1 second please. Okay, so once we actually created, so once we created all these views, so the next thing I'm going to do here is I'll double click on the analytic view. So here we already inserted a table which is C1 IDA. So from this table I selected the following columns: 1, 2, 3, 4, 5. Customer, material, company code, gross revenue, and sales deductions. So what I'm going to do now, I'll click on Star Join Data Foundation. I'll click on Star Join Data Foundation. So in the Star Join Data Foundation, we see the center table is the fact table. So I'll select each attribute view. I'm going to drag and drop at the data foundation. 80 customer, 80 material. So now I drag and drop three attribute views. Now we are in the star join data foundation. So I'll just try to arrange them. 80 company code, 80 customer, and here you have the material. Excuse me. So I'll go to the paint. So let's go to MS Paint once. So here if you see, now we are in the star join data foundation. We are in the star join data foundation, not at the data foundation. So in here we have attribute views, three attribute views: customer, material, company code. So on the other day, we executed these views individually. So these views are actually having the master data. This master data you're getting from a schema. All these tables you're getting from a schema. So likewise material, likewise company code. So this is one subject area. This is one subject area. Customer is one subject area. Material is another subject area. Now in the center you have one table, which is CE1 table, which is CE1 IDA. Excuse me. So now we're going to join these attribute views with these foreign keys in this table. So the point here I'm trying to make here is when you execute this, now which engine it executes? OLAP engine. We know it executes on OLAP engine. But we also highlighted one point when we discuss about attribute views. Attribute views execute on join engine. Attribute views execute on join engine. And analytic views execute on OLAP engine. But see, I'm using attribute views inside an analytic view. I'm using an attribute views inside an analytic view. So in this case, when attribute views are used inside an analytic view to provide master data, or this is a subject area. So still attribute views continue to execute on join engine, or they execute on OLAP engine. That is the question over here. Attribute views when individually executed execute on join engine. Join engine is optimized to process complex joins. But when we use the attribute view inside an analytic view, they skip the execution of the join engine. The entire analytic view creates a column view, which is a multi-dimensional view. So this column view also has attributes from the attribute views. This column view also has attributes from the attribute views. And this column view directly executes on OLAP, does not execute on JE. So what does this mean is, only when we execute attribute views individually, execute on join. Otherwise, when we activate the analytic view, it creates a column view of type analytic view, and this analytic view column view executes an OLAP. So it skips JE. It skips the JE engine. So I'll go back. Now we know, even though we have attribute views over here, when I click on this free space, when I click on the free space, TC, I click on the free space, the engine is the OLAP engine. So all these attribute views, including the analytic view, execute on OLAP. So even when you have attribute views, even when you don't have attribute views, like the ones that we created yesterday, like this, like KNA1, T005, T5U, we created like this yesterday. Everything executes on OLAP. So now all that I have to do now, I have to join the key attributes with the foreign key, MATNR to ARTNR, KUNNR to KNDNR. So once we join these views to a fact table, expand the attribute views. So here you see the attribute views. So here you see the columns. If you expand the attribute views, here the highlighted ones are not hidden. So these are all the attribute views. And these are the measures. Here you also can see calculated columns, restricted columns, input parameters. Now I would like to create a new calculated column. So I'll right click on the calculated column, click new calculated column. Calculated columns are used to derive some meaningful information in the form of columns from existing columns. So calculated columns are used to derive some meaningful information in the form of columns from the existing column. So from existing columns, we are going to derive a new column. Like, for example, I'm creating a new formula. I want to calculate net revenue. I want to calculate my net revenue. This column is not directly available in the table. I'm deriving this column in the runtime. So label, technical name is net revenue, label is net revenue. Expand the columns folder. So here you have these existing columns. I'll double click on the first column, VV010. I'll place the cursor, double click on minus. I'll place the cursor again, double click on VV070. So I'm trying to derive a new column based on existing columns. click validate syntax, valid expression. The one that I'm trying to derive is a measure. This is amount related data. So it's a measure. The data type is decimal, length 15, the decimal point scaling factor is 3. So data type, measure, length, scale, give the syntax, validate, valid expression, click OK and click OK. So here I created a new calculated column. So calculated columns are used to derive some meaningful information from the existing columns. Now we see there is another folder called restricted columns. Right click on the restricted column, click new. Restricted columns are used to filter the value based on the user defined rules on an attribute value. Let us take one example. For example, I can display the data something like this. Head count. Head count is actually a count of attendees that have attended the course today. So today I want to see how many participants have attended this course in today's session. So what I'm trying to see, how many are present to the course and how many are absent to the course today. So I'm trying to see based on my head count how many are present and how many are absent. For example, the total number of students present, the total number of students registered for the course are 20, for example. In this 20, 15 students are present and say 5 students are absent. Now, how can I display based on head count how many are present and how many are absent? Now, how many are present? 15. How many are absent today? 5. How many are total? 20. So what I'm trying to do here is I'm trying to restricted columns are used to filter the value based on the user defined rules on attribute values. So what are attribute values over here? The attribute values are present, absent. I'm trying to restrict head count. So can I create something like this? I can have 2 columns. In these 2 columns, one column head count for present, head count for absent. So this will give me in the morning session for HANA, the course is HANA. In the morning session, 15 students are present and 5 students are absent. So to achieve this, I'm trying to restrict measure head count on an attribute value. Same measure, but different attribute values. I'm trying to create different columns. Let us take one more simple example. I'll try to take simple example. For example, my gross revenue, I want to see for 2013, for 2014 and for 2015 year. So these are nothing but values inside year. So what is the column that holds these values? Year. And the other hand, we have amount. Gross revenue is nothing but revenue, which is gross amount. So what user want to do is, so if can we can display something like this. Okay, so here is there. So the gross revenue for 2013 is 10 million. For 2014 it is 20 million. For 2015 it is 30 million. I don't want to show like this. So instead of showing like this, I want to restrict amount. I want to restrict amount to year 2013. So instead of like this, I'll create 3 columns now. So year is an attribute. What value? 2013. What is the amount? 10 million. So what am I trying to do? I'm trying to restrict, I'm trying to filter values based on user defined rules on an attribute value. So I'm trying to do a restriction on an attribute value 2013 for amount. So this is called as a restricted column. You're trying to restrict. So in the same way, you can restrict for a company code. You only want to display for a company code 1000. For a company code 1000, additional restriction. So in the year of 2013, for what company codes you want to restrict? Only for company code 1000 for Germany. So for Germany, for the year of 2013, for Germany, for Frankfurt. So how many restrictions did I apply? 3. Year to company code to sales organization. 3 restrictions I applied on the amount. This is known as a restricted column. So what is the difference between a calculated column and a restricted column? Calculated columns are between 2 measures, like amount related data or quantity related data. But a restricted column is between an attribute and a measure. We need to have at least one attribute. Because we have to restrict on an attribute value. So calculated columns, we can derive a new column based on an existing columns. A restricted column is between a measure and an attribute. So let us create one restricted column. I'll go back to HANA Studio. I'll give the name as company code 1000 is the description. For company code 1000, I want to restrict for gross revenue, that is VV010. This is the gross revenue. For this gross revenue, restrictions, columns, select company code. AT company code BUKRS equal to what value? Select the value 1000. Click OK. So the attribute view is AT company code. In this attribute view, this column equal to 1000. For 1000, display gross revenue. And this is the column that displays the output. And click OK. So here you have a restricted column. If you want to edit, right click on this, click edit. You can restrict further. For example, for this company code, I want to restrict on a sales organization. Further restrictions. For this company code, for this sales organization, So I can do further restrictions like in this sales organization for this material, sheet metal. So this is nothing but the restricted column. I click edit. So these are the restrictions I applied to display this column output. Click OK. So input parameters. Input parameters we will see when we discuss about currency conversions. Just I will give one line answer for what is input parameter. Input parameter are input boxes where user can input values. For example, I'm having 100 USD. This 100 USD I want to convert to INR. 1 USD is 65 rupees. 100 USD is 6,500 rupees. So I'm trying to convert USD to INR. So USD is already there. So I input now. I input in the output. In the output box, I input as INR. So when I input INR, it calculates based on the exchange rates and produce the output. So input boxes gives flexibility to business to enter values. Based on that value, it produces an output. Like conversion from USD to INR based on an exchange rate. This we will see when we do currency conversions. For now, I'll just keep it blank. The first thing I've done is I added the table C1 IDA. I selected all the required columns. In the star join data foundation, these columns are available in the center table. I drag and drop the attribute views. I join the attribute views with the fact table. Attribute views, when they're inside the analytic view, executes on an OLAP engine. Individual execution of these attribute views are on the join engine. And then we started to create calculator column. Calculator columns are the columns that are derived from the existing columns. Restricted columns are the columns where we restrict measures on an attribute values. And finally, let us click on semantics. Click on the semantics. In the semantics, here we can see this is a symbol for restricted, this is a symbol for calculated, and type is a measure. Type is a measure. So both of them are measures. This is a calculated column and this is a restricted column. And here you see there is local, there is shade. In the shade, you can see keys. So these are the key attributes. So all these three are the key attributes, and these are attributes. So shade means, what do we mean by shade? Shade means we can share these objects in different analytic views. Local is specific to this analytic view. So these are only specific to this analytic view. We cannot share these objects to different analytic views, but we can share the master data. That's why it is known as reusable dimensions. So that is the advantage of native HANA modeling. So can we share this that we did that we created yesterday in BW? How can I share? I cannot share because this is specific to this view. But here, if you see the semantics, when we created BW and HANA like model, we don't have anything in shade. It is blank. Because this is specific to this, only this view, which is local. And here in the native HANA, when we create data models, we can share the master data. We can share this master data across different analytic views. And finally, what I'm going to do is validate this view and activate. So once we activate, the view is activated. Right click on the analytic view and click data preview. Click data preview and let us generate sample reports. Let me generate a sample report. Select Landex, drag and drop to labels axis. Select VV010 to values axis. So here we can see data based on different countries. United Arab Emirates, United States. You can Tucloud, the largest value shows has the highest gross revenue. These are the different options. So here you can see based on chart, table, grid display, HTML5 display. HTML5 display. If you want to filter, click on this icon. At the filters, click on this icon, which is toggle advanced filter. Click on this icon. Select Landex, drag and drop into the filters area. Click on show list of values. Select any country like USA, United States. Select, click OK. I'm just trying to filter. You want to do advanced filters in list. You can select multiple values. United States, Germany, United Arab Emirates. Click OK. So the amount, the time taken to process this view is 31 milliseconds. Now let's see based on company code. Based on company code, BU text, Germany, Frankfurt, UK, USA. Now, if I execute the similar kind of report, I'll go to SAP logon. I'm logging into the ECC system. K24, give the operating concern. Let us provide the operating concern. Let's continue. Enter the company code. Only 1000. Let me enter the company code. Only 1000 I'm entering. Best run Germany. So in HANA also, I'll just select only one company code. I'll remove this. I'll only select Germany. So Germany is nothing but 1000. Or instead of taking text, I will take key. Let us take key instead of taking text. So I'll just select company code here also, BUKRS. I'll select 1000, select, click OK. How much time it took? 24 milliseconds to display 1000. So if If I go back to ECC, here also I'm displaying 1000 company code and click execute. Display line items, execute. So here, to lead long runtimes, possibility of several hours, continue. So it started now. It started. Let's see how much time it's going to take. It started reading. It's reading 19,000, 44,000. It's still reading that value 1000. Only for one company code. It's still reading. It's continuing to read data. Already it is more than 10 seconds. Still continuing to read. Still it is reading. So anyways, so this is the time it takes on the source system. Now, this is what it takes in HANA. Not only for one, any combination you can select. Just drag and drop as to your wish. Any question you can ask. Based on company codes, based on customers, based on materials, based on... You cannot see more than 500 milliseconds. Any question you drag and drop here, you cannot see any. If you can drag anything that you want, you cannot see more than 500 milliseconds. So less than a second. So this is the performance what HANA can produce. But the real power of HANA can only be seen when you have mountains of data. What ECC cannot give at all. When you have mountains of data, instantly it can give any complex question within 3 seconds. So user can continuously interact with the system and ask question after question until he gets to the analysis where actually is the issue, and how he can, how we can resolve that issue for any kind of question he can ask. Okay, so this is how we can create analytic view. So in analytic views, we created an attribute views. So this is the native HANA modeling. We created attribute views, we joined with the fact table, we created calculated columns, restricted columns, and finally we see in the output. Now in continuation with this scenario, I want to continue this scenario. Okay, now we created an analytic view. We created an analytic view called AN. We created this analytic view called AN underscore COPA underscore actual underscore data. So this is the analytic view created. Okay. Now when we create this analytic view, where is the column view created for this analytic view? It creates in underscore sys underscore BIC. So can we see this? So underscore sys underscore BIC. So go back to HANA. When I click data preview, click raw data. I'm just trying to see the entire view data. Raw data shows the entire view, all the columns. Click show log. Excuse me once. Click show log. Double click on generate SQL. Let's double click on the generate SQL. Copy the entire statement. Let's copy the statement and copy paste this in the notepad. So in here we can see the select statement, select top 200 BUKRS, all the attributes. All these are attributes, and these are measures. And here you see insist BIC, attribute view, and the name of the analytic view. And finally group by BUKRS, BU text, WAERS, trying to group by. So I'm going to copy this technical name. I'll go to sysbic from HANA Studio. I'll close and close. I'll scroll to the top, expand catalog, go to schema underscore sys underscore bic. This is the system schema. Let us expand this schema. In the column views, right click on the column view, click filters. We want to only see that view. Copy paste the column view. Copy paste the column view. Click whole word. I want to match this word. Click OK. And expand the column view. So here you see the analytic view. The one I created here in the package. The one I created in the package, I can see in the sys underscore bic. I'll double click on this. Double click on this. So do we see all the selected columns of the semantics? So all these columns like net revenue, company code 1000, all these are the output. So here you have, so this is, the view is flat view. So you have attributes and measures. Click on create statement. So here we can see the code that is generated by system. And we cannot modify this code. This is just, we cannot edit this code. This is generated by system. So this is the column view that is going to execute on OLAP engine. So this column view it executes on the OLAP engine. My next scenario is, so we created one analytic view for actual COPA. I want to create the similar scenario. I want to create one more scenario where I can create an analytic view for plan. I can create an analytic view for plan data. So instead of actual, I want to use CE2 table. So I want to create one more analytic view that is for plan data. So simply what I can do here is, I can copy the actual to plan. And I can change the table. So here I'm using CE1. So instead of CE1, I use CE2. Here we have two important measures, VV010, VV070. This is gross revenue and this one is sales deduction. So instead of these measures from CE1, in CE2 I want to use plan gross revenues, VV010001, VV070001. So I'll go to HANA Studio. So first what I'm trying to do is I'm trying to copy this view. I'm copying this view. I'm copying this view. I'll close catalog. I'll go to the content, to the package. I'll go to the package. So this is the view I just created. Right click on this analytic view. click, copy. Right click on the analytic view folder, right click, click, paste. So I'm going to change the name from actual to plan. I'm just copying as a template. Click OK. Object copied. Click OK. AN COPA plan data HANA. Double click. The view is still inactive. You see there is a small symbol at the bottom which is inactive. So still we have CE1. But CE1 table is for actual. So I'll right click on this table, remove. I'll remove this table. The following references to the columns will also be removed or adjusted. Are you sure you want to continue? So some of the columns like VV010, VV070, I'm using them in the calculated column and restricted column. So do you want to remove? So if you remove this, this will get affected. Click yes. Later I will adjust the view again. I will adjust the view. Click OK. I removed the table. I'll click on the new table. CE2 IDEA from best schema. Click OK. So I tried to replace CE1 with CE2. So once I replace CE1 to CE2, now please see in the star join we have the master data because master data can be shareable. I can share master data, only the objects in the local are deleted. So I need to reselect these columns from the data foundation. I'll click on the data foundation. I'll click find. I'll find for KNDNR, ARTNR, VV01001, VV07001, BUKRS. I selected all the columns. Click on the star join. Now you see, we can see one thing here. I selected BUKRS, but in the output it displays as BUKRS_1. If you notice here, for the other columns KNDNR is displayed KNDNR. For ARTNR it displayed ARTNR. For BUKRS it displays BUKRS_1. Why? It creates an alias column. Why it creates an alias column is because in the star join, if you see, I already have BUKRS in the company code. In order to differentiate this BUKRS with this BUKRS, it automatically creates an alias _1. So now I'll again join BUKRS to BUKRS, material to material, customer to customer. I need to adjust this calculated columns. I'll right click, edit, remove them because these are old measures, old technical names for actuals. I'll remove, expand. These are the new measures. Technical names are different. Double click, minus, double click. So here we can see gross revenue minus sales deduction, validate expression, and click OK. So we need to tweak to the adjust, we need to adjust to the current requirement. I'll edit again. So instead of this VV010, we need to replace with VV01 0001. Click OK. Once we adjust all the required dependencies, I'll click on semantics, validate, and click save and activate. And finally, we have the new view for plan. Right click on plan analytic view, click data preview, expand, so drag and drop VV01 0001, drag and drop Landex. For plan, we only have two countries data, Germany and United States. This is for plan. But if you see for actual, right click, data preview. For actual, when you drag and drop Landex, VV010, we have for countries like Germany, United States, Norway, Italy, Great Britain, Austria. So all the data for actual is in this view, and the data for plan is in plan data. So what is my next requirement? So here I have two views, one for actual and the other one for plan. So my requirement here is, here I have actual measures and here I have plan measures. So I want to produce a report that can give me output from both actual and plan. I want a report that can produce from both actual and plan. How to design this? That is the next question. I design, this one gives me actual and this one gives me plan. So plan, it gives me for Germany and United States. For actual, it actually gives me for different countries. Now I need the combination of them, and also I can actually, you see, you have actual for United States and you have plan for United States. I want to calculate variance between both of them. So how can I achieve this? So we know, how can we achieve measures from two different fact tables? Calculation view. So on Monday session, we start with how to create calculation views, how many different data categories we have in a calculation view, different scenarios to create calculation view. We start on the Monday session. We take both of these analytic views as a data source to create a calculation view. Thank you for attending today's session. I'll see you on Monday. Any questions, please type in your chat box. Once we complete, I can answer your questions. Have a nice weekend to everyone. Thank you. So we'll see the questions now. I have a question. How does user interface for end user looks alike? Can they drag and drop the various fields and put questions based on filters? Yes, they can do that. So end users have different ways to report. For example, they can use apps on mobiles. They can use web reporting. They can use Excel. They can use Excel as their reporting. So end users who are comfortable using Excel can use Excel. Comfortable using web can use web. comfortable using mobile, can use mobile. So we have various interfaces on how we can expose this data. That we will see in the data reporting. Data reporting, I will show you how we can expose the data to the end users. In the native modeling, is it mandatory to always define the fact table at the data foundation? Can't we add the fact table in the star join? No. The output of the data foundation is only then it gives the star join data foundation. Data foundation is especially for a star join. We have to define the central entity. So please see, if I double click on the view, so here if you see here, there is a property called central entity to the data foundation. So the central entity should always be the center table. Means, so this is the table that will actually give the fact table. So here you see the data foundation. Now if you insert a table here, you cannot see the data foundation. So next question. While selecting the tables through code words, TVKO, in addition to this, is there any possibility to get the display of hint about the actual name of a table apart from the technical names? Yes, it is always there, but I am actually, to tell you very frankly, I'm wantedly using these technical names. The reason I'm wantedly using these technical names, not to make it complex, but participants who are not new to SAP can at least get this idea about how the SAP technical names are there. Descriptions are always easy to understand, but when working in the real world scenarios, most of the time we commonly used to get these technical names because descriptions are very confusing. One description for several technical names. Like for example, sales order ID in VBAK is VBLN. Sales order ID in VBRK is AUBL. Sales order ID description is same, but you see the technical name is different. So that's why it is commonly we get used to these technical names, but we can also make it easier in the training part at least. So whenever we are moving these tables to HANA, we have an option to move with descriptions. For example, I'll just show you. So here I have taken CE1 table, right? Now this table is without descriptions. So I wantedly selected without, but you can actually CE1 IDA. If you select from any of the schema, you see here, you'll have a table with descriptions. Like MNDT means client, KNDNR means customer, ARTNR means product. So this is an option to select the descriptions. So if you right click on this table, show complete name or show description. Now it doesn't show the descriptions. See here? It's similar. Now when you right click on the table, show description, show the description. How can we use time attribute views in an analytic view? Okay, so here, when I right click on an attribute view, click new, AT underscore time, I'll create a time-based attribute view, Gregorian, I'll take date, click finish. I'm creating a new attribute view for time. I validate, save and activate. I'll finish. So now I created a new attribute view called time. I'll double click on actual. I'll just select the time attribute view, drag and drop inside the star join. So we have a new time based attribute view. So here I'm going to select a column. For example, let's select HDAT. This is a date on which record was created. So in the star join, here I can join this dates to the date to the table. So I can join this. This is the foreign key and this is the primary key. So I'll validate, activate. So now what I can do here is I can do time-based analysis. Now when I right click on the analytic view and click data preview. Now please see when I actually selected HZDAT. So if you see the HZDAT, you can see from a table HZDAT. When I right click on the table data preview, when I select HZDAT, I'll just search. So I drag and drop. Now please see, HZDAT is in the form of dates. You see, year, month, date. Now my requirement is not to see data based on dates. I want to see based on year. I want to analyze my gross revenue based on year. So what I can do now, I can right click on the analytic view, data preview. So I'll select year column. So because I already joined based on date, I can select year, drag and drop into labels axis. And now I can drag and drop the gross revenue. So now it displays based on different years. So 2014 has the highest revenue. So in the same way, I can also further distribute by month, gross revenue by month, gross revenue by week, gross revenue by day. So if I want to filter on a year, for example, I want to filter on a year which is 2014. 2014, I further want to filter, drag and drop the month on the month of February and the week of 5. 5 doesn't have data. So what week we have data here? 6. We have data for 6. For the week of 6, this is my gross. The year, month, week, day, these are the days. So the granularity at which I am actually seeing the data gross revenue based on different time dimensions. Now this is the use of time to analyze data based on different time dimensions for the given requirement. So let us see the next question. So can we have filters? What's the use of restricted columns? Restricted columns we are designing at the design time of a view, but filters are at the runtime of a view. Now user tells me very clearly, he gives me a layout saying that, okay, this is what the data I would like to see in this column. We're not actually giving opportunity for the business. We're not giving opportunity for business to do filters. So he actually tells me, okay, this is what I want to see. This is what I want to see in the report. design for me. So based on his input, I'm going to, yes, as you rightly said, we can also do with filters, but actually it depends on business requirement. Whether you want to give choice to business or whether you want to do it. So we should be able to the best judge because we are actually technically capable. So if you ask me for a particular column, these attribute values are not going to change. These are fixed. So you have 5 columns. So these 5 columns based on a company code should only display for the last 5 years, like 2016, 15, 14, 13, and 12. Report, the question is fixed. No one can change this question that I'm asking. Company code and the consecutive 5 years gross revenue. Only this question I want to see. We have to go for restricted column. Can we able to see field names as well as descriptions for a table? Yes, you can see. You can see both field names and descriptions. If this is the field name, when you highlight the descriptions, you can see the description. As we just see now, I added a new table. I click add C1 IDEA from, you can see both field names and descriptions. So in an attribute view, we are able to add filter in the data foundation. Can we add a filter in the star join? Yes, you can do that. You can still add filter in the star join also. For example, I create a data foundation. At the data foundation, I only want to show data for company code or the column that is not available. Okay, I'll take this PLIKZ. I apply filter. 0. I only want to show values that are 0. Again, I further want to restrict on currency. WAERS. I think sorry, it's not currency. WERKS. FRWAE. FRWAE. This is currency column. Foreign currency. You see, I created 3 filters in the design time at the data foundation. So even we can do filters at the attribute views. Right click. You can apply filters on a company code or sales organization. And further, the output of this attribute view, is then passed to the analytic view. In the analytic view, again at the data foundation, I can do further filtering on a table. So it applies a filter over here. Based on the filter condition, it transfers the data to analytic view. And again, it applies this filter and then it produces the output. Thank you, everyone. I think these are the questions we have in the chat box. Thank you, everyone, to attend today's session and have a nice weekend. And let's see you on Monday again. On Monday, we start with a new topic that is calculation view. Thank you.